So, as I said, I wish to show you three simple things in elementary mathematics that I often use in my Math 10B or Math 100 classes when it comes to motivating the students. And the first such thing is rotation of the Earth around its axis. We are all moving at a speed. And the first goal is try to estimate the speed at which we people sitting in Fresno are moving. This is pretty simple math. We know what geographical latitude is. It's the angle between the plane of the equator and the point on the Earth. So F stands for Fresno over here. It's roughly exactly that geographical latitude. And it's pretty easy by elementary trigonometry to determine the length of each parallel on the Earth, which in case of Fresno is simply about 30,000 kilometers. Once we have the length, we can easily find the speed, our linear speed of motion, because, well, you divide the distance by the speed, by the time, and you get the speed. Please note that that speed is supersonic. So a related question is, how fast could we get to the Atlantic Ocean if Earth stopped below our feet? Or being on the East Coast, how fast we would get to Fresno? 3 hours. Number two, this is an old problem about wrapping up the Earth with a rope and then adding 1 meter to that rope. So I put it in a real life situation that we can see the rope running across my friend's driveway. Now that when we add 1 meter, then the question is it enough for a cat to walk through that semicircular gate? And obviously everybody can believe easily that it is perfectly possible. Here's some computations. We have the arc length of 1 meter. We have 4 cats whose combined width is about 60 centimeters. So these 4 cute cats can easily walk through. And now we do a different thing. Imagine that we now rearrange our rope into a perfect circle. And the question is it far enough off the ground for a knife blade to be squeezed or for a cat to crawl beneath? That's a really highly counterintuitive thing, because take a look at the answer. The answer is it's about 16 centimeters, regardless of the size of the ball in question. It's the same distance for a basketball, the same distance for Jupiter, and so on and so on. And now, the last one is, suppose that a cat is 15 centimeters in width. You see, 266,666,666 and 2/3 of a cat can pass under that rope at a time. And the last problem. That's a true story. When I was an elementary school student, the question that you can see in front of you was asked by my uncle. And I pretty easily guessed that it's a great problem, a great puzzle, because all it takes is to have your tent on the North Pole. This picture explains everything, right? We make 3 sections of our walk and we are back to our starting point. So then I started thinking and I discovered something very interesting. First of all, when you take a look at the Northern Hemisphere, there's obviously no other points with that property except for the North Pole. But for some reason, I struck upon an idea that drove me into this very interesting observation. If you imagine the red parallel, that's 1 mile long exactly, and you start your walk from the green one that is exactly 1 mile north of the red one, then of course you will get back to where you started. And my last question, are these the only 2 possibilities? And it turns out, and I need to give credit to my colleague, Dr. Bishop, who drew my attention to that fact, that actually there are infinitely many such pairs of a red and a green parallel that would work, because you see the math at the bottom of the screen. All it takes is to have the red parallel a fraction of a mile and traverse it several times. Thank you very much.